Welcome everyone to the Joint Research Group and Web of Things, Web of Things meeting. This originally planned to happen in Helsinki, but of course, obviously, due to the recent changes, now we're also having this meeting online. And I hope you right now. Well, as I mentioned at the beginning, we are recording this session. Also, as a general policy, in T2TRG meetings, remember to be nice to each other, accommodating our questions, and also the IPR guidelines of the IETF do apply on this meeting. For of the chair's slides of the privacy code and conduct and IPR policy. A few words about the goals of IETF. Sorry?
Can you press mute all?
Just a moment.
Thank you.
All right. Everyone should be muted. So please keep yourself muted unless you are talking, then we'll avoid the background noise.
Okay.
Thank you. So let's continue. So IETF meeting, staff meeting, and here we are focusing on the long-term research issues of the internet. So we are not doing standards development, although we do have close collaboration with the IETF, where there is a lot of standards development happening. And we do publish occasional information on experimental documents, but the key goal is those exploration and research IoT. A quick administrative, we do have notes. There's a link in the chat. There's also the first link on the slide. Please go over into the meeting minutes as a beginning. As for the mailing list, if you want aware of meetings and other information about T2TRG, we highly recommend you to join. You will get invites to these kind of meetings and everything else related. We also do have a GitHub repository, as we do have for T2TRG meetings. There you can find the latest information, agenda slides, and other relevant materials. We're gonna do collaborative note taking. Some echo now, please. We're going to do collaborative note taking, so feel free to chime in the notes. I will be taking some notes there, but anyone is feel free to add whatever has been missed. But we're planning to experiment with slightly different notes than usual, not doing full transcribe, but rather put the key discussion items and a timestamp on the notes, so then we can refer to the recording for more detailed aspects whenever needed. So you will be seeing some timestamps on notes that refer to when was that discussion started. We will plan this a 3-hour meeting. We'll plan in halfway, have a roughly 20 minutes break. We are running from 12 Zoom. Apologies for everyone in the West Coast. That is pretty much the only way for us to accommodate both US, Europe, and Asia in a somewhat reasonable time frame. But we do have meetings in different times to accommodate for different people. Words about the T2TRG research group scope and goals. So we are a research group, and for the key issue we're focusing on is turning the real IoT into reality. Quite a bit focused on the constraint nodes and how they can talk among themselves with the wider internet. But in particular, we are focusing here on aspects that have standardization opportunities at the IETF side. So starting at the IP adaptation layer, working up all the way up to applications, management, APIs, and of course not forgetting security. And at T2TRG, we do a lot of collaboration with the IETF groups. For example, Core and Elwick are two groups we have close collaboration with. So there's a lot of intentional overlap in the work, and oftentimes documents starting from one group and moving to others, and documents being built and drafted together. Also in T2TRG, we have this activity called Wishy, and this is a slide actually we showed in our previous joint meeting with T2TRG Web of Things, where we have a lot of overlap of interest, in particular in this meeting on the modeling of data interactions for IoT and also REST-based hypermedia for IoT. But there's a set of other topics also what we have in the Wishy activity. So if you are interested in working together on those topics, we welcome you to join our Wishy meetings. A few words about our history with the T2TRG Web of Things. So one of the goals of T2TRG is this facilitation of coordination and collaboration between the IETF, IRTF groups and other IoT-related organizations. So we have been closely in collaboration with the T2TRG Web of Things pretty much from the beginning of both of the groups. So we have had sort of face-to-face and online meetings. We're doing technology development and exploration together. We are building tools together, having common hackathons, etc. So this meeting is a continuation of many set of meetings that we have on these common topics. That was the intro part to the background of this whole meeting series, and here's the agenda for today. And Michael McCool, co-chair of the Web of Things group, would you like to get the overview of the agenda?
Yeah, maybe we can use the agenda on the web page because it's more up to date now. This one's a little out of date. Anyways, let me share my screen. And so the first thing here is just do an update on the Web of Things. First of all, can people hear me okay?
Yes.
Okay, good. All right, let me just share. So there's a link to this presentation if you want to look at it later on. And let me just try and get this going. So, So the Web of Things is a working group and an interest group within the W3C. The interest group is an exploratory group, and the working group actually develops standards. They were both recently rechartered, and actually the interest group was rechartered in November, and the working group was just rechartered actually in April. We actually started the process much earlier, but because of various delays, we had to delay it. However, we're both now rechartered for another 2 years, and there's a number of new work items on the table for the second round. Now, the previous round we just finished, we did publish two W3C recommendations that I will summarize briefly in a minute. But, and then I'll also talk about the new work items and what we're now working on. Now, the general goal is to adapt web technologies to IoT, but that covers a lot of territory. Another goal is to not repeat things that are done elsewhere, and so we're trying to find appropriate gaps to fill and to enable interoperability. And we're looking at basically the application layer and not at the protocol layer. Okay, so we're trying to work above the layer of protocols. In fact, one of the goals is to allow cross-protocol adaptation and allow a single uniform application layer to map to many different protocols. So the diagram below is meant to invoke this idea of a narrow waist, that we have a single abstraction that acts as a narrow waist between the application layer and all the various protocols. One of the key strategies here is a descriptive approach, where we describe how systems work so that the adaptation layer can use that description, rather than using a prescriptive approach where we try to tell people how to do things. We recognize there's already a lot of things out there. There's a lot of brownfield devices. There's a lot of competing ecosystems. And so rather than playing the game and trying to get everyone to switch over to our system in a prescriptive approach, instead we're going to describe things that already exist and try and integrate with them. Now, I'm going to talk a bit later on in this meeting about discovery. That's one of the themes of this workshop, and I want to overview where we are with that right now. And this basically boils down to, if we're doing a descriptive approach, how does somebody find the description? And I think this is a key component to actually make the system work. However, let me first describe what we have accomplished. So we recently published two specifications, the WAT architecture and the WAT thing description. The WAT architecture basically describes the high-level constraints, the use cases actually, which Michael Legali will be talking about our recent work on for the next round, and also an abstraction. So we have an abstraction at the application layer that is basically, describes the affordances that a device can do without, and then we also have a protocol binding which describes basically how to map the high-level abstraction down to, the actual protocol layer. But the idea is that the mapping to the protocol layer is done automatically by the system, and the user, the application writer, only needs to worry about the high-level abstraction. Now, the WAT thing description is a JSON LD 1.1 file that embodies the description of a given device or thing. And this is just a short little brief snippet to show you the general idea. So there is, because it's a JSON LD file, there's a context file that defines basically links for all the terms, so we can use RDF as information models. However, we've avoided a dependency on RDF, so you can also treat the thing description as a plain old JSON file and just read it that way. So you can do semantic processing if you wish, but you don't have to. And especially for small devices, you don't have to. If you're just producing or consuming a TD, you don't need to deal with the JSON LD for a lot of use cases. Now, the connection, however, with RDF is that semantic tagging and annotation can be added to thing descriptions, and this is where we believe there's a connection between activities like the one data model. But other than that, you basically have properties, events, and actions as being the main affordances. Somehow that got lost here. But and then for each of a property, event, and action, you can have data models for the interactions. And the data models are done with basically a JSON schema style syntax, but which also applies to other payloads besides JSON. This is our overview diagram for our use cases. And so thing descriptions can apply to a lot of different use cases. They can obviously apply to, like, looking at existing devices in a local network. They could also apply to things like proxies, where you need to bring data into the cloud, let's say. It can also apply to things like digital twins in the cloud, that or databases in the cloud that need to ingest data from a device. And also gateways and synchronization. So you might have to hold data for offline devices and create like a shadow of them. So we are now in the midst, and Michael Legali will speak to this, of reviewing our use cases and our requirements, and doing a lot more work to dig into detailed use cases and extracting requirements. But I will let Michael talk to that. Just to mention that the applicability of thing description is actually quite broad, and this is kind of good news, bad news. So we are trying to narrow down precise use cases so we can get our requirements nailed down. A good example of requirements we need to look at are security. What exact security schemes and protocols do we have to support? What exact actually communication protocols do we have to support, and so forth. Another thing that the Web of Things enables is orchestration. We currently have two systems that have been built that are available to do orchestration. Others are, of course, possible, but there is a scripting API document that's been written and has been specified. It is currently an informative document, and there's an implementation of it called Node-WAT, which is on ThingWeb, and this is a Linux Foundation project, I believe. No, Eclipse. And so you can get an implementation of this. It runs inside Node.js. It's actually a TypeScript implementation, so it's also strongly typed. And this follows the specification that is being written as an informative document. There's also visual language support. So there's a system called NodeGen that can take a thing description and generate nodes in Node-RED So you can drag and drop to talk to devices described by thing descriptions. And the basic benefit here is you can, if you have metadata, you can automatically populate a Node-RED dashboard to be able to select devices. And this is actually something we're looking at for our retail use case, as I'll mention in the POC discussion. Right. Okay, so let me talk about the new work items. So at a very high level, you can see there's a bunch of different things we're doing. Now, some of these, most of those in the first column, are really just maintenance operations. So things we have to just fix. And so a good example of this would be, default for observe. Right now we have, some protocols have an observe interaction, but it's not clear on, say, for example, HTTP, what the default is if you mention which one you're using, because there's 6 different ways to do it, or not that many, but so just to make it easier to write a TD, we like to define some defaults for some of these. That's a simple example. Another thing that'd be useful is we have links, but we don't have defined relational types for various applications. For example, I might want to link between a TD and a template for that TD. So a template applies to a class of devices. A TD applies to a particular device, an instance. So it'd be nice to have a standardized relational type for that to connect the TD to its TD template. That's just one example. There's lots of different relationships you might have to define between things. There's already INA types for lots of link relations. So the issue here is just, can we pick a particular relational type and give it a precise definition in our use case? In the middle column is more complicated things we need to do. And so one of these is profiles. So one of the problems with a descriptive mechanism is it's open-ended, so it can conceptually describe all kinds of new things that may not exist when the spec is defined. So that's great. The problem is when an implementer comes along and needs to implement something, and they want to know that it works out of the box, they want to know, they want to have a finite set of things they need to implement. So we need to state, what are the finite set of things that an implementation has to support in order to get out of the box interoperability. And so the approach we're taking here is to look at profiles. This is still ongoing work. We're still discussing precisely what needs to be in a profile. So there's also, besides like, protocols that are supported or not, or schemes, security schemes are supported or not. It's also things like how should we have limits on string lengths for finite devices and so forth. This also relates actually to the topic I'll talk about later on for discovery. If TDs are unbounded in length, it makes protocol for discovery tricky. And then I mentioned templates already. This concept needs to be refined. It turns out there's multiple use cases for templates, and we have to figure out what the requirements are and make sure that the template's satisfied. For example, should security schemes be in a template? Should there be a URI template for forms, etc.? How do you know what protocol a thing is going to use from the template if a form is not included? That sort of thing. Complex interactions we were talking about today, and this is basically the idea of using hypermedia controls for things like actions and events. Also, we talked about discovery today, which is basically how do you get a thing description. Other topics, which we won't get into, identifiers. We're actually looking at decentralized identifiers as one option here, but there's also the issue of things like rotating identifiers. What if I have a thing in a directory and the identifier changes? Do I want to rotate it? How do I notify people, etc.? Security schemes, we've been talking about OAuth lately, and other possible schemes, and we need to figure out what schemes we need and what the use cases are. And yes, and also I guess there's been a lot of work lately on MQTT under protocol vocabulary, and generally speaking, new protocols are being considered. Okay, so as I said, we talked about a bunch of these things today, in particular, the complex interactions and discovery, and also the use cases. Anybody have any questions or comments at this point? Okay. Anyways, I just want to point out the slides, a bunch of links if you want to follow up on reading. Yeah.
Maybe a quick comment on the queue control. So since we are not a massive group, whenever if there's a natural pause to ask questions, go ahead and chime in. If there's more discussion ongoing, you can always put a Q+ into the chat of the WebEx, and then we'll be picking up people from there. But both options are available for you to on questions and comments. Thanks.
Yeah. I think everything works.
So raise hands in WebEx.
Yeah, that would work too. I should also mention at this point, please review the agenda. Oh, hold on a second, I'm trying to exit here. People should also check they're on this list for the attendees, so make sure we capture everybody. Take a moment to review that. Some of the people logged in didn't use their real name in the WebEx, so it's hard for us to know what to put here. I think that was Ken's been captured. That's good. Okay. Anyways, I think we should go to the next item on the agenda.
Okay. Thank you, Michael. I guess the next one is the use case process overview by Michael Lagali.
Okay, can you hear me?
Yes.
Okay, good. Okay, sharing my slides. So I just uploaded them on a branch, on a fork, and will create an MR after I presented them. I'm going to talk about the use cases, and I have a combined presentation. So I have a couple of topics that I want to talk about. One is use cases, then I have life cycle, the state where we are, and then I can quickly outline what we are doing with profiles. Michael already introduced the topic when he gave the entire overview about Web of Things work items in this charter period, and I have a little bit more details on that one. I'm the editor, co-editor of the architecture task force. I'm driving the work there, and we have quite a lot of things on our plate. Let me just increase my... Okay. I just got a crash report from PowerPoint. Sorry about that. Let me open it again. And share it again. And click on the slideshow button again and hope this is working now. Okay. So architecture task force specific work items are to talk about requirements, use cases, vocabulary. I'm going to talk about that in detail. Then specific link relation types to define the types here. Going into interoperability profile, collect requirements and define a plugin mechanism for having a plug-and-play interoperability of different devices where you just combine them out of the box and put them together in context, hook them up to consumers and start working with them. Thing description templates, talking about classes and things, classes of things, and an inheritance mechanism and modularization of thing descriptions. Complex interactions, already mentioned by Michael McCool. Lifecycle, this is where I'm going to go into more detail. Terminology for states and transitions for products, devices, and information. Onboarding, how trust can be established between things and gateways, and identifier management. So in this presentation, I'm going to cover requirements, use cases, and vocabulary, and the work we have been doing so far. I'm going to talk about the interoperability profiles and the lifecycle work. And in terms of use cases, we do have 20 new use cases in the pipeline, and more are to come. So while we're speaking, people are creating merge requests and contributing with use case descriptions. We do have a template which is simple and straightforward. It basically asks for motivation. It asks for what stakeholders are involved in a use case, what kind of typical flows are there, potential variations, and already trying to assess the potential gaps and things that need to happen to Web of Things specifications, multiply architecture, thing description, security, protocol binding, and others. We have active contributions, and I believe this list is outdated. We have additional contributors. Specifically, we do have Fraunhofer and a couple of others. So if you're not in the list and on this call, apologies. This slide is a little bit older. In terms of target domains, we include smart cities, industrial domains, transportation, manufacturing, logistics. So you may say, well, industrial and commercial deployments, as well as also home use cases, smart cities, smart grids, healthcare, retail, and several technology use cases, which are more or less horizontal. So they are touching and affecting multiple domains. These are the use cases and categories that we currently have been collecting. 2 slides. I'm not going to read all of that, but they're very important, just the high-level bullets. So one of the very essential points is multi-vendor system integration, which means interoperability out of the box, being able to define digital twins for devices that allow to create complex models, that allow simulations, that allow troubleshooting in real time by having real-time data, doing predictions, doing analytics, minimizing downtime, notifying people about downtimes, and also performing simulations. Multi-vendor and protocol interoperability is an important use case in general. Communication across different protocols, having gateways, being able to transfer the same abstract level in terms of thing description, in terms of, I would call it, device model across different protocols. Then we have a couple of accessibility use cases that were contributed and included from an MMI group. We have automotive use cases. This is just an exemplary one, smart car configuration management. We are not trying to be exhaustive here. We are trying to find one key use case for a category and for a domain. And if there are many variations or additional ones, we're trying to get the key requirements for these specific cases. Then for energy and smart grid, we have a use case for integration of generation, storage, grid management, and consumption of energy. Transportation, we have a very generic collection of descriptions about fleet management for public transport, shipping, air cargo, train cargo. Smart buildings, 2 use cases right now. Commercial buildings, large-scale buildings, and also sensor networks for more privately managed smaller buildings. Then shared devices and resources, a critical point when a device can be controlled by multiple users, how to make sure that they don't interfere and don't issue contradicting commands, for example, issue contradicting actions, conflicting things.
Michael, do you want to take questions now?
I have another slide, but we can take questions on this slide, yeah.
Josie, go ahead.
Oh, I just saw the next slide at agriculture on it. I was going to ask about manufacturing and agriculture because this type of approach is really good for it. So I saw it in the next slide. So I think you'll answer my question in the next slide.
Okay. If not, then just chime in again, please.
Go ahead, Michael.
Then we have retail, where we interconnect and integrate multiple devices into common retail workflows. Audio video, that's a use case contributed by a broadcaster to synchronize home devices with TV program content. Agriculture, smart agriculture, greenhouse horticulture, to create an optimal environment for growing plants by combining sensors and gateways and measuring all kind of environment data, including temperature and climate, to optimize the plant growing environment. Smart city, to manage mobile devices and sensors in a smart city. Health monitoring for public health and private health. Specifically, well, it gained recent attention due to coronavirus. Manufacturing, to monitor production lines and plants and predict and prevent fault conditions by having, well, metrics and sensor data and being able to find deviations of expected behavior quite early, anomalies. Multimodal system integration, that's another MMI use case and category. A common device lifecycle model, I'm going to talk about that further on, and something that came in recently, use cases for OAuth 2 flow, to be able to make sure that we address the right requirements and the flows that are needed. So these is the current list and the initial list we're working on. We have decided, and we want to shortlist the use cases to make sure that they address real market needs and also to make best use of limited resources. And we also want to prioritize use cases that grow the IoT market in general and also the water adoption. So we want to focus on the deep level requirement analysis and future work to make sure that it meets market demands. So we try to answer the primary question of what advantage the use of what brings to spec adopters. So this is basically the process that we are implementing, where we are in the yellow-orange block at the moment. So you can imagine a timeline on the bottom of the diagram. We have a list and a set of use cases. We are doing a short listing. I'm going to talk about the process in a minute. And based on the short list, we do another iteration where we go into gaps, identify potential new building blocks that need to be addressed. One obvious candidate is a discovery component and a corresponding directory. Another potential outcome can be a gap of an existing specification. And these are described in requirement documents. So we already started to do that. And also system configuration can be a gap. And these requirements then address different deliverables. So security, privacy, guidelines and documents, thing description, scripting, discovery, and profile. We are almost starting to have a vote. So we want to ask all working group and interest group members about their personal or company's assessment of the use cases. So we are conducting a W3C questionnaire. We plan to publish it this week. It is basically asking for all of these use cases, whether there is, whether this is a business critical use case for a respondent, whether it is less critical, whether it's nice to have or completely uninteresting. And also in terms of future work and doing the deep dive, of course, we're looking for domain experts and champions who can help to identify requirements to make sure that the work is well grounded on expertise also. I already mentioned it. We create a one-page requirements document. We follow a template, and there's a couple of examples. The work has started, but we are currently more in the consolidate use cases phase, and just starting on requirements. We have, I think, 2 or 3 examples at the moment. One more word on the interest group use case task force that we recently started for collecting additional use cases. So we realized that if we are doing this work only in the Web of Things working group, we are limiting the scope, and we are limiting the domains to only working group participants who are already members. And we want to make sure that we collect input from a wider IoT market audience in terms of scenarios, in terms of use cases, in terms of requirements. We are trying to be as open as possible to get all input on the plate, to review everything, every contribution, and to make sure that the Web of Things specifications match and address the requirements from a wider audience. So we are trying to get as many voices heard as possible. And if this is an open invitation, if anybody on this call has additional requirements, has additional domains that go beyond what we are currently looking in, have additional requirements, have additional ideas, please let us know. Please participate in this task force. We are conducting usually bi-weekly calls. The next call is going to happen on Thursday in 2 weeks. This week is a public holiday in Germany, so we are canceling this week's call. So the next one is in 2 weeks. And the output is going to be an interest group document where we are collecting and describing every input. So everything that's contributed is going to go into this document without any shortlisting or anything. Okay, that's the material I have on the use case work that we have been doing so far. Are there any questions?
Did you include a link to the use case repo in your presentation?
I have a reference section at the end of the deck.
Okay.
Okay, in terms of agenda, I think now would be Michael McCool's turn again. Or am I probably have not seen the latest agenda, so I can go on.
With lifecycle.
Okay. Okay, good. So in terms of lifecycle, we have been conducting discussions during the last couple of months in the architecture task force. So we have the goal to describe the operational lifecycle model across different standards. We want to describe the security model, we want to describe state transitions and states, and we don't want to impose any new lifecycle on any of the adopters of the standard. One goal of this exercise is to align the terminology to make sure if we apply Web of Things on a specific protocol which has an underlying state machine or a deployment model or security provisioning scheme, that people understand the same, well, have a notion of the same terminology. And also this is important for our work inside the Web of Things group to make sure that also inside the different specifications we use the same terminology. And that's a general objective also of the architecture spec, to define terminology, to lay the groundwork in terms of architecture, in terms of conceptual introduction, in terms of terminology across different Web of Things deliverables. We want to identify requirements on architecture, security, thing description, and other deliverables by this lifecycle work. And we looked into several lifecycle models. So we looked into OCF, 1 M2M, lightweight M2M, and also the RFC 8576 from the T2TRG. We have a proposal on a unified state model, which is in discussion. We are planning to conclude on that within a couple of weeks. We have an agreement on fundamental states, state names and transitions. There may be some changes, but we are pretty much aligned, I would say. And this is the current draft where we start. So we have different layers. We have the manufacturing layer, manufacturer's layer in the bottom. Then we have the providers who is offering a service. The actor could be a manufacturer, a service provider, or also the device owner. On top of, we have the application itself, application because there is also the embedded, well, runtime, which exposes scripting APIs for consumption of the underlying web of things thing applications. I'm probably not, well, we don't have enough time to go into all of the details, and things are still in discussion. I wanted to include this slide to give you a general idea where we are working on and in which direction we go. So basically, we have the initial state, which is manufactured, or at a later point in time, it can also be a state when a device is being basically reset into the initial state. When it has been decommissioned, it is going to be treated like a new device that is going to be onboarded in a different scenario or to a different consumer. Then we have the bootstrapped and onboarded state, which is usually including assigning an identity, assigning ownership, doing some initial provisioning of keys, of security, certificates or tokens. And from this state, we are going into an operational state. There are two different layers here. The operational, which means that the device is basically connected and reachable via protocol. And what operational includes a little bit more. It includes also that an application is running, or an application is working and implementing the behavior of things. And from this state, from the operational states, which may be on a specific device, it may be a single state. Also, when we have a simple sensor device, there is no what application, so it's just a plain operational state. And from there, we can go into maintenance and reprovisioning keys, doing software updates and things like that. And from this maintenance state, go back to manufactured or, well, decommissioned. And we also consider a destroyed or permanently disabled state where a device intentionally is no longer active and can never be reactivated. This is important for security critical deployments. We also have been started.
Can you give a quick summary where you had to extend or deviate from the model in RFC 8576?
So the intention is not to deviate in any way.
Okay.
So
that one has been around for almost a decade, and it turned out to be pretty stable. And it would be nice to have something like a mapping between the 8576 terminology and the terminology that you are developing. Of course, you have identifiable components that we are not discussing in 8576, so there is going to be some difference, but it would be nice to have some mapping.
Yeah, I completely agree, Carsten. We don't want to introduce or invent or reinvent the wheel. We don't want to impose new requirements on devices. We want to describe what's out there in the field, what has been adopted. We have this additional application component, which may have some additional consequences in terms of key provisioning and things like that for dedicated use cases. But you should be able to find your model in this picture. And if not, please shout or reach out to us and help us.
Certainly one thing that came up, Kirsten, was the need for layered keys. So it turns out devices get provisioned with keys several times at different layers. And that was a little tricky to capture. There isn't just one provisioning step. You actually have layers.
Right, thank you.
Okay. Then we also started talking about system lifecycle, where a thing lifecycle, which is basically modeling just what happens on the device, into a wider system lifecycle where a device is registered with a thing directory, or also registered with a consumer, where some initial trust level has to be established with the consumer, and also something may have to happen on a consumer, like having a list of device IDs that are registered and that are trusted and that are permitted to send information, send data to a consumer, like when you think about cloud service use cases where multiple devices can provide sensor information. You want to make sure that devices are authenticated and that our devices are authorized to actually consume and or generate data for the service. Same thing applies to a thing directory when an additional component in the architecture needs to be introduced. We currently don't have explicitly in the architecture picture a thing directory, and this has this extension has some consequences. And this is just an example to illustrate. This is a proposal, so it's not yet consolidated. It's just something to illustrate also things that we need to look into, where we have a device and we have a consumer. And on the left-hand side, we see the device owner, and on the consumer side, we see somebody who is operating the consumer or owns the consumer. It can be the same guy. And at some point in time, the device, after it has been initialized or started, it is registered in the directory. It is published in a way and can be discovered by somebody who wants to use it and hook it up on the consumer. We need to work on the state transition names on the message names here and align them, so these are coming from different sources, and we need to make sure that we are using the same names. So you won't be able at the moment to find a mapping between these names and the diagram in the previous picture. Just a word of warning. So we're working.
Michael, I have a comment here, but before that, there's someone else in the queue ahead of me. Marie has been there for a while.
Okay.
I'm not there anymore. I was answered.
Oh, you were, okay. Yeah, my comment here is note that discovery is actually also needed during onboarding. So if I have a new device and I have to register it with the system, I have to discover the places to register it with. So discovery isn't just about discovering devices that have already been onboarded. It's also about devices figuring out how to connect and onboard to an existing system.
I think we need some additional flows here. And this is just one example flow to show the different entities that we have, and specifically to show that there is a thing directory which is going to be involved in some additional flows and use cases.
Yeah, and actually one example of a flow complication, discovery can go either direction. So I might discover devices that want to be onboarded or in an onboarding state. I might also have devices discovering infrastructure they can onboard to. And different protocols approach this different ways, which adds complexity to the problem.
I agree, and that would be another flow, a different flow. Okay, and that concludes the part on the life cycle. Are there any questions?
You said you uploaded your slides somewhere, but I didn't get where.
I uploaded them to a fork. I did not yet have time to create a merge request. It's on my fork of the T2TRG repo.
Okay.
So Michael, I put my presentations under the Watt presentations directory in the Watt repo. Maybe you can put the presentation there and just share a link later. I think after the meeting's okay.
That's also fine. Profiles. So that's also one of the charter items for the architecture group. The architecture itself, the architecture spec itself and the thing description define a powerful mechanism and a format for describing very, very different devices with the intention to be able to describe everything that's out there in the field. That's in the brown field. However, there is intentionally and by design, there are only very few normative requirements on devices. And we have a couple of use cases that require more interoperability in terms of out of the box, in terms of, if I get a new device, I don't want to create a new client. And in general, if you wanted to implement a generic client for all kinds of thing descriptions, it's impossible to implement. Just imagine one flavor of a protocol that's only used in a specific device, maybe because it's an implementation bug and behaving specifically in a way, or whatever. Or imagine complexity in terms of thing description length and depth and all kind of plain simple things like maximum length of strings, where many implementations still assume it's 2 to the power of 16, 65,000 something characters. So the motivation is to make interoperability easy, which means to create a profile and by first generating a generic profiling mechanism, which can be used to describe a profile or multiple profiles in an unambiguous way. And it's not limited to a single profile. We can be defining multiple profiles, but in terms of having improved interoperability, we also want to define a core profile, which means to define a subset of the thing description for use with selected protocols, define additional constraints. There have been several plugfests that were conducted in the Watt group, and tests were done during development. So a lot of work has been already done, and things have been identified to work, and things have been, some reasonable baseline assumptions have been made. And this knowledge is in the interest group, it's in the plugfest participants' heads and in some documents, and this can be formalized in terms of a formal profile specification. Additional profiles, for example, for thing templates or other protocols will be defined. This may be happening as part of the profile work. It may be happening also potentially in the thing description specification itself. We're going to see how the work turns out. This is just illustrating at a very high level what we are talking about when we consider a Watt core profile. So if you consider all the vertical blocks, just the expressiveness of what we can describe in a thing description with a protocol binding, then the core profile is defining a subset. It is selecting features of properties. It's making additional constraints, the same on actions, the same on events, on links, and on security. Last year, we had a submission of a profile, Strawman, which is a very early write-down of basically thoughts that I was having when I was thinking about what needs to happen in terms of improving interoperability. So it's an Oracle submission. It's available publicly. It's in the GitHub repo. I have a link later on in the presentation on that. It also defines or describes and uses a generic profiling mechanism. I hope it's an easy to read document. It needs significant discussions and more work, and it's just a company contribution. So it is not something that has been agreed on so far, or that is an output of a working group. The work on the profile specification unfortunately stalled for several months since the architecture task force has limited bandwidth in terms of calls, also in terms of time that people can work on. So we pushed the profile work a little bit out since a couple of months. And as Michael mentioned, we are going to have an upcoming face-to-face in 2 weeks or 3 weeks. And the profile work will be resumed there, and I hope we are going to make progress quickly. These are the promised references. So we are on GitHub. There is the architecture repo. There is a subdirectory in terms of use cases. All contribution documents, proposals for lifecycle are under proposals lifecycle. And the profiles specification is on a separate repo. And that concludes the slide part of this slot. So are there questions, discussion items? And we are running a little bit late, and I'm sorry for that.
Thank you, Michael. If there are no more questions, we can move to the next part. But thanks a lot for doing this, especially the use cases work. I think it's highly useful for us to share those use cases across organizations, because that's a common thing that we need in our standards work on different protocols and data. So I think it's highly useful that you have a very open process for that.
Yeah, one thing we should mention is, I guess we're in the middle of consolidating, but one of the issues is categories, like, what big buckets do use cases fall into. The other issue is horizontal versus vertical use cases. So we have a bunch of vertical use cases. We also have a bunch of same horizontal technologies, let's say, like discovery or security or whatever, that kind of across those. And so as we do the requirements, we're going to be sorting out a lot of that, I hope, and trying to organize things better. But right now, I would say we have a large amount of input that we still need to put into categories and organize, and also prioritize, as Michael was saying. But I think more input is always good. I think we'll probably do a round of consolidation and prioritizing. But I think we'll always be. I think collecting use cases is an ongoing activity, and we'll probably be collecting more as time goes on and refining our models.
Exactly. And just again, an invitation, if you have any additional use case, and we can certainly spin off another call dedicated for this discussion. If there is anything you want us to consider and to take into account, please just let us know. Okay, and I'm going to create a merge request with these slides in a minute.
Great, thank you. Then I guess we can move to.
I already put your slides into the repository because I found your repository and copied things over.
Okay, thanks a lot, Carsten. Okay, let me stop sharing.
Yeah, we are 12 minutes late, I think. So Michael, if you can do the discovery thing, might be able to compress the break a little bit, but you still can do it in a little bit less time than we thought.
Give me a second to share my screen.
Hey, Karsten, could you check out what you copied across? Because I think you grabbed the HTML, not the PDF.
I did. Wait a minute.
Thank you.
Okay, so people can hear me? So I want to talk about the work on discovery. So we created a task force just to work on discovery. And later on in the presentation, there's a number of links to a repository that has a lot of design and requirements documents that kind of back up some of the stuff. We don't yet have a draft, public working draft of the actual spec, but the intention is to create a separate specification document that would define the discovery process. One of our challenges with discovery is not reinventing the wheel. So we don't want to, conflict with existing discovery mechanisms. In fact, we want to build upon them. So I'll talk about that in a minute. The other thing I want to say at the outset is discovery is defined in our use case as the mechanism by which you retrieve thing descriptions. It's not necessarily on the LAN, like it's not like a broadcast, mechanism. It could be across the internet. You could look for TDs that are in Singapore near the park or something like this. So we actually, even though you're saying in Canada. So I think that we are looking at a generalized problem of simply finding TDs. So, I started by writing down a number of requirements. So one is, just a set of things we should be able to do. And this kind of relates to the use cases. I think that, one thing that came up was people wanted to do localizable discovery. So you want to be able to say, I want thing descriptions in a certain place or location. This actually gets tricky because we don't currently have a standardized geolocation mechanism for TDs. And we also, want to be able to do, discovery that spans network boundaries in some use cases. So I might want to look for things across a campus, for example, and maybe over several network domains. We also did a lot of work in the past on semantic queries. And so because we are adding semantic annotation, we want to be able to have some ability to use that information. And there's a lot of great technology available. At the same time, we don't want to burden, simpler devices from having to deal with a bunch of RDF stuff. So we have to walk the same line we do with the TD is how do we support semantic query without burdening smaller implementations. And we also have different use cases. So we have large numbers of things we have to worry about, and we might need a directory service for that. We also want to do self-identifying devices, so devices that have one TD and they just want to make it available. Now, to make this all more interesting and complicated, we have to preserve privacy. So TDs contain a lot of metadata about devices. When devices can be associated with a person, that metadata can be used to infer things about a person. And even just getting access to the metadata can allow you to infer things like location. So if you knew, for example, what set of devices were near a person, you might be able to infer the location of that person. You don't even care about the actual information in the metadata per se. You're just using it as a fingerprint. So there's all kinds of privacy risks we have to worry about, and W3C is very sensitive about privacy. So one of the things we have to come up with is a way to do this, to discover metadata without blowing privacy. And so we need to worry about a lot of things. First, Bulwark is, distributing things only to authenticated and authorized users. The other thing is, plugging leaks. So not broadcasting metadata, but instead putting it behind a firewall. And we have to be it's tricky because we have to worry about inferencing problems. So it's not just, you can't just say there's no PII, no personal information in a TD, so don't worry about it. It's not true. because you can always use information in TDA to infer things from relationships. And this is a very tricky rat hole. And finally, like I said, we don't want to reinvent the wheel. So how do we align with existing standards? How do we build upon them, and so forth? And finally, there's discovery support in the scripting API. We make sure that that works and is simple to use. And in contexts in which privacy is an issue, it shouldn't be leaking information that could allow people to do like fingerprinting. So it's a tall order, lots of things. So as a first step, I had a proposal, which is basically using a two-phase architecture. So the idea is to have an introduction phase and an exploration phase. Another name for introduction would be first contact. Basically, how do you start? You don't know anything about the environment you're in. How do you start the discovery process? And so, one of the issues here is it needs to be open. So we don't have any access rights to start with. So, we have to have a way to bootstrap without having access rights. It shouldn't be heavyweight. So, small devices may need to do this. They may need to do it even when they're onboarding, as mentioned before. So it has to be lightweight. And but it shouldn't leak privacy information. So we have to actually, because we're having it as an open process, that first bootstrap phase should basically have no metadata about devices. It should just be kind of an onboarding process. So the idea of the two-phase approach is that you do kind of this first contact protocol, and the only purpose is to figure out how to actually access the metadata. Before you can access the metadata, you have to authorize with an exploration service. Now, later on, I equate exploration with directories, but actually, in theory, you could have other ways to do exploration, as long as it satisfies the properties that you have to authenticate against it before you can get access to metadata. But I'm going to talk at length about a directory service, which would be a normative specification for a service that would be able to respond to a request for TD metadata. In fact, another way of exploration would be accessing TDs directly from a device without going through a directory service, but that would have the same requirements for authentication and authorization in order to satisfy the privacy requirements. Yeah, some more information on this. The output, the first contact, is the address of an exploration service. And for example, a URL for a directory service. It does not have to be a broadcast mechanism. So one of the things we've been talking about is using DNS, and using DNS maybe that spans the network, maybe even using extensions of DNS that do location-based discovery. It could also be federated directories. So actually, you might have one directory introducing you to another one. The one requirement we state is that when you get a URL back, you shouldn't be baking information into that URL with the type of device. So don't return a URL from your introduction that is like my insulin pump, right? Because you don't want to have any inference from the name of the URL what the type of device is. So even if it's a self-identifying device, that introduction URL needs to be opaque in some way. We've looked at multiple ways of introductions. So you could have all kinds of things to do introductions. The only constraint, as I said, is that it gives you a link at the back end. There is already some specifications for self-identifying devices, like the .well-known thing. We need to clarify exactly how that's used. And then for several other mechanisms, we need to add a few bits of information. For example, to use DNS SD, we have to define the service name for our services. There's also issues with certain introductions only having fixed URLs or fixed addresses. So how do we map from a fixed address to something that might be in different places of the network, depending on, NAT and registrations and so forth. Now there are the relationship I'll mention later on to core RD, et cetera. A lot of these systems basically have a list of typed links. And so what we can do with these kind of mechanisms is use them as introduction services, have a typed link for a directory service, and then point to the directory from something like a core RD. So the idea is don't pack all the metadata into these directories or these kind of services. Instead, use them as an index into a directory service. The reason being is the directory service can have strong authentication authorization before we release the TD metadata. We may have different types, and I think the two main types that come up are pointing directly at a device that self-identifies its TD and pointing to a directory service. So I think we might, at the minimum, have two different types of links that need to be added to things like core RDs and DID documents and DNS, etc. Let's get that. Okay, so then once you've gone to the first contact, then you need to do exploration. You need to authenticate. And then an authentication may actually require something like OAuth. We have to go off somewhere else and get a token and come back. And then you can get access to a directory service. Now, a directory has a number of TDs. So you have to have a way to select the ones you want. So we realized that there's different layers of query. You might want to do simple query or template search. You might want to do full-blown RDF Sparkle queries. Not all gateways will want to implement a Sparkle query mechanism. So we are looking at some intermediate lightweight mechanisms. I'll mention some later based on JSON path and so forth. There's also issues with timeouts, so time to live. There's a problem that if something's registered directory and the device dies or goes away or is moved or something, we have to have a way to clean out the directory of obsolete devices. And also we need to have an onboarding mechanism. So when devices onboard, they register themselves with their directory or the directory discovers them in the opposite way. Let's see. Yeah. And there's also this issue of IDs. So one of the things that came up in the privacy discussion is rotating identifiers so that they can minimize the tracking surface. But if a device changes identifier, then the directories need to be notified of the change, and the directories may need to notify users of the change. And so there has to be kind of there may have to be a notification mechanism for if you want to rotate identifiers. And the idea here is that if a malicious user cached a TD from long ago, they have the old ID. If they're not on the notification list for the updates, they don't get notified of the new change, and so they would not know it. Okay, so privacy. Okay, so this two-phase approach is nice. It helps us get some privacy, but it's not sufficient. Okay, there's also the problem of even if I just get a list of directory services that are available in a certain location, I can use that to infer the location of the person finding the directories. So the API design can't even, in a browser context at least, give me a list of available exploration services, because that could be used as a fingerprint, my location. So we need to instead have a directory mechanism where we say what we want, and the system somehow magically gives it to us, and only if we're authorized to have that information. And so we have to be very careful about how we design the APIs to make sure that we're preserving information and let people infer things they shouldn't know. And I'm also, by the way, looking at an orthogonal problem of a non-browser execution contexts like edge workers running in a gateway, and they may have different requirements than in the browser. Okay, so I actually wanted to point at a number of things that we've done. And I'm actually going to give you a grand tour of what we have in the WAT discovery repo. And so these are the links, so later on you can look at this. But basically, we have some proposals, and the only one here really is the two-phase directory system. But we also are collecting, implementations, and one of them I'm going to talk about later on is the Fraunhofer LinkSmart system, which is a prototype directory service, basically. We also have, been collecting requirements. So we have, sets of requirements about things, and this is kind of where we get alignment on what we need here. One of the things we need to do, though, here is connect these use cases. So once the use case stuff sorts itself out, we need to look across it horizontally and confirm that we, have captured the right requirements for the use cases that we're actually considering. It's a bit out of order. In theory, we do the use cases first and then extract requirements, but I think we're more in the iterative prototyping model than the waterfall model. Given the requirements, then we have a bunch of design decisions we've been discussing. So we basically made the resolution that the two-phase architecture makes sense, and we will follow that strategy. And then some details there. Now, one thing we're in discussion, though, still is what exact introduction mechanisms we need to support. It turns out that different introductions may need some additional work to enable for this. We, for example, need to define a service label for a DNS-SD. For DIDs, they return a bunch of typed links. We need to define some type labels for DID documents for those to be enabled for DIDs. For QR codes, we have the problem that the QR code may be printed, in which case it's fixed. So how does that work? How do we, maybe we're in a home environment and we're behind the NAT, so we don't actually know the URL or the IP number of our device. So how do we actually go from the QR code to the device or to the TD? And actually, it's kind of related to the problem of how do we have stable URLs for TDs. So one way around this is to use DIDs, which are decentralized identifiers, which then provide a stable identifier that can be resolved into a set of links, and those links can be updated. But that's still in flight, and we're not quite sure. I think if QR code is on a display, though, it becomes a lot easier. If you can display a QR code or in some way display or broadcast a discovery link, then you can update it. And one version of that is actually a Bluetooth beacon, which can be used to broadcast links for discovery. But now this is for devices that are broadcasting their label or their directory service. The other way around is devices discovering directories and registering with them. So we also have the issue of making directories discoverable. There's also well-known locations. And so we need to define, what is the well-known location for a TD. And the basic idea here is the simplest possible exploration service is you just get to a particular location and you'll get the TD back. However, that get should go through an authentication process, which would have to follow the HTTP protocol for requesting authentication, because you don't know in advance necessarily what authentication is needed for this link. We also, like I said, looking at directory service, we've made some decisions about things that, we're going to stick to TCP, HTTP for now. I think in the future, we might consider other things like CoAP, but for now, to keep the scope simple, we're going to define it in terms of TCP and HTTP, and actually TLS. So we have to, of course, have the link encrypted in order to provide any kind of security or privacy. Another design decision, which actually is up in the air right now because we're still debating it, is JSON versus JSON LD. So does a directory return JSON or JSON LD? If it returns JSON LD, then the implication is that it needs to have a context, and it needs to have, queries should also, obey the naming rules for for semantics. This actually is kind of tricky, and we are currently debating how to do this. One of the issues is a lot of the query mechanisms are allowed to return partial or part of a TD. But then it becomes tricky to define what the context is, especially if you have nested contexts or things like this. So we are currently just realized, in fact, just last week, of some complications if we do want to support JSON LD. And so we're currently debating how to do this. So right now, the decision is listed as just pretend it's JSON, but we'd like to figure out how to do the semantics correctly. And this is semantics in the context of keyword searches, right? So if you want to do full semantics with Sparkle, of course, it's JSON LD. This is in the context of a lightweight keyword template-based search. Another issue that comes up is pagination. If you have, a directory service with, say, thousands of TDs, you give it a query that basically says, give me all your TDs, and you could have a really, really huge download. And so we don't want to do that in a single transaction. So instead, we want to paginate and have, next, next, next kind of things. And we are looking at an interface that does one TD at a time, pagination. However, currently TDs can be unbounded in length, which is don't want to have a gigabyte long TD as a pathological example. So we need to probably look at this and either have profiles that limit the length of TDs and or have some way of paginating through a single TD if it's especially long. And this is actually also needed for protocols that have limits on metadata in a single transaction. Finally, for query mechanisms, we've been looking at query support and different ways to do query. I think Sparkle is kind of like the best way for us to do RDF and semantic query, and it's fully general. It's also very, very powerful and is maybe overkill for small devices. So we're looking now at the LinkSmart system I mentioned before, has both JSON path and XPath prototyping, and we're going to be experimenting with that in the PlugFest next week. And it actually does support pagination and other things. There's also the issue of metadata. So what if we have extra data about a TD, like, for example, the timestamp at which it was registered, how old it is, what its time to live is, that sort of thing. So we can't necessarily add that data to the TD because later on, we're contemplating in the security group adding a way to sign TDs with a JSON LD proof section. So we don't want to invalidate the signature by having the directory modify the TD. So we have to figure out how to do out-of-band data returns. And so very likely the information model for the directory will have metadata associated with TDs, but not part of TDs. And we need to think about an information model for directories that allow that. Let's see, what other interesting things are here. We have to decide what authorization schemes to support. So similar to profiles, we'd like to have a finite number so that people know exactly what we need to implement in order to support directories. And so far we have this short list that we want to have at least the basic stuff, but we also want to have some like tokens support mechanisms where the credentials to get an authorization token are provided in a separate device than where you actually use the authentication. One final thing that we think is interesting, design decision, is the directory network API we want to describe in a TD. So the directory service itself is essentially a virtual thing. And why this is interesting is it allows directories to index other directories. So that means we can have federated directories where we can search a directory. Instead of finding a thing, we might find additional directories where we might find more things. So a discovery process might end up being recursive, and walking through a bunch of directories. Of course, we have a way to limit this, and one logical way to limit it would be by spatial location or doing spatial query. So what we have to then look at, how do we get spatial information, or number of network hops or number of directory hops. So we just, however, right now we're not really looking at that. We've just made the decision to make the directory API in a TD as a description that allows us to do this later on. I think right now we're not specifying how to do recursive search. Right, and there's a bunch of other things we're talking about with IDE. What is the exact set of introductory mechanisms and so forth. Okay, so that's all I want to say there. And again, this repo has other information here. I won't go into it, but we have some background information as well. And if I go back to my slides. So I have a couple links here on prior work and background. So there's been a lot of work, and we're trying to index existing mechanisms for discovery and figure out how they can work within the WAT sort of architecture. And also, we're still willing to accept additional proposals. One thing we wanted to do was capture previous work in previous years for discovery, especially for semantic discovery. Right now, the LinkSmart system that we're looking at is really focused on the lightweight keyword and template-based search, not on semantic search per se. Well, you can certainly do keyword searches for particular semantic keys. Okay.
Michael, we are already 10 minutes into our break.
Oh, we are. Okay. Well, I think I'm basically done. I'll skip this. And I had some discussion points. I guess what we should do is, yeah, sorry, I went a little long. So
interesting, we had some of this discussion last week in the last.
we did, but not everyone who was here was at that discussion. Maybe I can simply summarize. Do we want to take 5 minutes for discussion and then have a break, a delayed break?
Yeah, we already have a delayed break, and we cannot go under 10 minutes for a break.
Right.
So I think we should have that break now.
Okay. So why don't we have the break, and then yeah, let's discuss the agenda when we get back then.
Okay.
Okay. So 10-minute break, and time wise, hold on.
So we are reconvening at 13:40
Right.
world time. And those who have slides for the next segment, please make sure that Ari and I have those, because we need to upload them.
Okay. So 40 past, we'll reconvene.
Yes.
Let me stop sharing. Ari or Kirsten, is one of you there right now?
I am.
I'd like to propose what to do with the agenda here.
Yes.
So if I can have 2 minutes to wrap up, and then I think what we should do is defer discussion to some later meeting, either a wishy call or a discovery task force call. So I think it's tricky because we're about to go into a podcast face-to-face. So I'd like to identify a point which we can have discussion and then defer it. So what's your next wishy call?
That's on June 30th. So there already is a little bit of agenda for that, but I think we should be able to accommodate that.
Okay. So I guess I just want to say small more things. First of all, identify that. And then also just mention, I guess, that we need to do some work around picking a query language and picking introduction protocols. I think is our main activity next little while. But I think the discussion points can also include things like core RD integration.
So I pushed the link to the agenda items
Okay. For the next
on the chat.
Okay.
So how should we call that agenda item?
I'd say what discovery discussion. And I would link back to this presentation so that people.
Can we get this a little bit more specific?
What's that?
Can we get that a little bit more specific than just what discovery discussion?
It's basically discussing this slide. So I wanted to have some discussion time in this workshop. It's not going to happen now. So I want to continue to get feedback on the WAT design, basically.
Yeah.
So, but I think it's actually good to give people time to think about it, and we can follow up. And I'd say, let's say, 20 minutes, whatever we had scheduled for discussion in the workshop.
Well, we had 10 minutes, but that was so.
10 minutes then, yeah. Let's do 10 minutes. 15 minutes even. 10, 15. Yes, you're going to add that to the agenda for the next wishy and add a link to the wishy to the current agenda on the workshop.
Yes.
Okay.
So I just sent the link to the agenda in the chat.
Okay. Well, it's 40 past now, so maybe we should restart.
So we're now at the end of the break. Hopefully everyone is back. The next agenda item is the proof of concept. But Michael, do you want to briefly wrap up on what we decided on the way forward with the previous
yes,
agenda item?
we think we have to defer the discussion of the WAT discovery. So what we decided to do is push it to the next wishy call, which is June 30th. And on the chat, Karsten has a link to that agenda. And we will follow up on the discussion at that point. And basically, I'll discuss the last slide in this presentation, and we can follow on. We only have 10 or 15 minutes of discussion time, but we don't have time for it. So let's move on. So what was next on the agenda?
You.
I am, okay. POCs, right?
Yes.
Right, so how much time do I have? 20 minutes total?
Well, the total is 20 minutes, but who's presenting Jennifer's smart city thing?
Jennifer, do you want to talk to your slide? I can bring it up here. Give me a second.
Sure. And my slide is just a single slide, so it should be very short.
Okay, give me a second. And let me start slideshow. Okay.
So to give a quick background, of course, one of the problems that GovTech has is many fragmented protocols for sensors and robots. And so this is why we've been working with the W3C Watt team to look for solutions that can solve this problem. And of course, Web of Things is what we're considering. And so what you see here is a list of the potential use cases that we've discussed with the team here on potentially what GovTech is looking to solve with WOT. And I'm not going to read all of them, but basically, long story short, the only one that is basically in production or going to hopefully go under production is the one that you see in the image spot on, which is a smart thermal sensor. And right now it's been shipped and created, and it's a low-cost thermal sensor that detects high temperatures in crowds. And of course, one of the feature requests that we received was to see all the high temperature locations, and if, say, like an agency purchased spot on and deployed multiple ones, to see it on a map and find the areas where there might be like potential fever hotspots. So that is one of the strong contenders we have for POCs right now, and the rest are still under investigation, but we look forward to potentially like adding them as we get our POC created. But in any case, that's all that's from me.
Yeah, and I should say we're capturing these as general use cases in the architecture working group, but we feel these use cases apply to more than just Singapore. They're general smart city use cases. Okay. People can hear me, right?
Yes.
Okay, so I'm going to, now the next set of use cases we have are a retail POC. And David Azell, I'm not sure, are you here, David? Okay, I didn't see David on the list of attendees, so I'm going to assume I'm doing this. But David Azell is, we've been working with Connexus, who is a W3C Watt member, and they basically represent convenience stores and gas stations in the US mostly. And so that's kind of the context we're looking at. And I'm also in collaboration with Intel on this project with the Intel Open Retail Initiative. So, so basically, there's lots of different use cases for IoT in retail. Now, what's interesting is a lot of these also involve computer vision or AI. So one of the things that comes up is, and actually one of the reasons for Intel's interest, frankly, is that there's also orchestration of IoT devices with AI applications. You have things like RFID scanners scanning product codes. You have door sensors. You have security systems. You have person identification and tracking, et cetera. And some of these are AI-based sensors, and some of them are just plain old, switches on doors. So, so we've been collaborating. We're working with Intel's Open Retail Initiative, which is a project under the IoT group within Intel. Now, they've sponsored an open source project called EdgeX Foundry, which is actually a collaboration among many companies. And so part of the POC is looking at integrating Watt into EdgeX Foundry, which will enable not only retail use cases, but other use cases. And of course, Connexus is driving the use cases. And kind of our plan was to get things done and able to showcase that in the fall for a conference called NACS. We're not quite sure it's going to happen because of coronavirus, but we're assuming it is, and we're working towards that. Okay. And actually, we're looking at a particular, concrete use case. Someone walking into a convenience store and buying an ice cream. And the idea is the person would walk in, they'd open a freezer door that might have a sensor. They might use computer vision to identify here's a person, and also look at the product that's being taken out, or maybe an RFID sensor, identify the product. And then the person either walks to the counter, and if we assume the associate is in the back room, they have to be notified to come to the counter to check out the person. Alternatively, the customer might decide to walk out the door with the ice cream. in which case we have a different kind of notification process to worry about. And so we might just want to simply remind the customer, hey, you have to pay for that, or to, like, tell the associate you've lost inventory. So, the architecture, involves, working with EdgeX as kind of the coordination system, coordination platform. There's various input devices and display devices and AI systems and things like notifications that need to be integrated. And actually, one of the things we're looking at is maybe you have an IoT device for your freezer door, maybe you have an AI system for the freezer door opening. And so ideally, the application layer shouldn't care. It should be the same application regardless of whether it's a real device or a virtual device. The other thing I wanted to showcase was end user programming. In the retail environment, you may have to often adapt a system to a given store. That adaptation may have to be done by someone who is basically, a sysadmin, not really a programmer per se. It might even be the store owner. And so how do we make that accessible, kind of as easy as making a spreadsheet for end user? And so we're currently looking, actually, first of all, EdgeX, we're looking at modifying these parts. So adding TDs to the metadata system, and actually probably running a directory service for probably the LinkSmart directory service, and then adding some kind of orchestration capability based on Watt scripting and or Node-RED. Node-RED is our #1 goal here, because we feel that Node-RED works really well for end user programming. Right, and so this is kind of our plan, and so we need to mine the metadata available already and generate TDs, and then figure out how to integrate our directory services with EdgeX, and then support things like Node-RED orchestration, and then finally stand up an example based on that example of buying ice cream. That's it. So I think we probably have a little time for discussion. It was, I guess, 10 minutes out of 20. So we have 10 minutes for discussing POCs or use cases. I do want to distinguish POC from use case. I think a POC is we're actually trying to build something. Use case is we're defining where we might build something, or someone might build something. I think they're related because very often we have a use case and then we also build it. And there is a retail.md use case in the architecture repo that captures the retail use case, and there's a bunch of different use cases for smart city.
I was a bit taken to the side by the fact that I had to sort the slides a little bit. Did you say how the results of those experiments are documented?
Well, it's not done yet, so we haven't gotten the documentation part. I will say that for PlugFests, one of the things I've been trying to do is more formally capture our results from PlugFests. And I think, as part of the PlugFests, we definitely want to walk through some of these POC implementations and capture, the pros and cons of different approaches. I think that, for example, for this POC for retail, we're going to be going ahead and using the LinkSmart directory, okay? Even though it's not necessarily normative for what we plan to do, it's not necessarily decided that's going to be the interface. So we're going to do something, we're going to try it, we'll see how it works, and then try and capture the results. I think the idea, though, is we have a report out on these POCs that would provide feedback into our use cases.
Okay,
where's
that report going?
It would be on our repos most likely. So we have a use case repo. That'd be one place to capture this. We also have a testing repo where we generally capture PlugFest reports. I should say we're trying to capture data formally now in terms of CSV files for different pairs of things that interoperate and how well. And so I'll have to think about what kind of data we can capture for POCs. because they're essentially a complicated plugfest scenario. I think a POC is a bit more because it's kind of out in the world. So a plugfest scenario might just be just us guys talking. I think a POC is something where we actually are out in the world and there's actual real users using it. And so one question here is, should we have questionnaires or something to like capture information or more formally capture feedback from users?
Okay. Any other questions on the proof of concept?
I saw Taylor raise his hand. Someone raise their hand on the.
I cannot see raised hand, sorry.
Okay, you must have taken it down then. Okay. Any more questions then? Okay. Anyways, we have a POC meeting, by the way. Then we alternate right now between retail and smart city. If you're interested in joining that, send me an email and I can invite you. It's an open meeting. It's an IG. Oh, Taylor is back. He was asking about Sidewalk Labs. So can you speak up and ask your question? So they have not reached out to me, no. I'm not sure if Taylor can use audio. Taylor, can you speak? Okay. Taylor, why don't we follow up by email then? I mean, I'd be interested in talking about what Sidewalk Labs is doing and whether there's a POC there. That would be very interesting. But so far, we haven't had any discussion of that nature.
So Taylor, can you type your full name into the chat? Okay. Thank you. So I think we are done with the current segment. So Michael Costa will be next.
Okay. Let me first. Here we go. I don't have slides, but let me just summarize really where we are with one data model. This is mostly W3C and T2TRG. We have a website that's about almost ready to go live. Our SDF language has an internet draft that's proposed that you can go read, that basically contains the official documentation for the language. We have, among other things, a playground. And the playground basically has a fairly comprehensive collection of data models, all in SDF format and all more or less validated. I noticed a couple of things that still need to be cleaned up, but for the most part, these are all valid data models. So I'm basically going to go straight on to explaining what SDF is and how it does. But basically, at one data model, we are basically managing both the language, SDF, and the set of common models that we're working on to converge across industry. And, Karsten, ought to jump in if you want to add anything to that summary.
Well, we had a pretty extensive discussion of SDF in the Singapore meeting, and actually the video from that is out there as an SDF tutorial. So if you are interested looking more into SDF, there's an like 20-minute tutorial that you can watch. But the basic idea is that it makes sense to have a very high-level view of the data model and interactions provided by a certain kind of thing. And that's actually what SDF allows you to capture.
Okay, so for example, I hope you can see my text editor. Here's an example SDF file for a very simple on-off switch definition. And there are some things like namespaces that work in a very similar way to compatible to how they work in JSON LD and in thing description. There are some definitions of objects that are encapsulated sets of events, actions, and properties that have the same semantics as a thing description, and I guess we're all aware of that. So yeah, right. There's Carsten just put up the tutorial. So this example has a definition of a switch object, which is some functionality, functional encapsulation, on-off switch. It has an on action and an off action. It has a state property. And the data defined the state property as an enum with the string values on and off. And I wanted to show that to sort of illustrate and for some grounding on how this actually would be used in a thing description the way we've used things so far. So I've taken a switch description, and a thing description will use definitions from one data model as semantic tags or semantic anchors to for interoperability around concepts and these terms that are defined. So where we saw a switch defined with on and off actions and state, the thing description here is going to describe a thing that is a simple switch and has no more than just the switch in it. So its type is, and basically I've created a namespace here that kind of points to where the definition is, and it uses this JSON pointer syntax, which is the same as used in the SDF model, to point to the definition. So here you see this capability namespace cap expands to 1DM exploratory cap, which is a model that's going to be in the exploratory folder in 1DM. Pardon me. And this thing description basically describes a switch as defined as an SDF object. So it has a property, it has a state property that's defined as, again, with that type annotation that points to the state property definition in the SDF file. And it has an on and off actions that each point to their respective definitions in the 1DM file. So the type is SDF object switch, SDF action on, and that sort of uniquely defines that definition without any name conflicts within that namespace and across namespaces, and points to these unique definitions. Now there's no linked data behind there. You can't go there and expand that. That's basically going to point to this this node in a JSON file. So there's some further work to to expand these through the IoT schema activity to give them a little more semantics behind there. But this is basically how you would point to elements of a definition. We don't really need to worry about what's behind that at this point. So this is basically the obvious way of using thing description, of using SDF one data model definitions in a thing description. So I can build thing descriptions that are have semantic anchors in them that are based on these definitions in one data model. Right, so I can make thing descriptions now. So to point out, these have no protocol bindings at all. They're completely protocol agnostic. In fact, they're mostly representation agnostic. The idea is to not even to try to pardon me, to try to not even nail down enums to a specific set of representations, but allow some late binding and overriding even on those. So SDF is not really in the business of creating protocol bindings or describing any instances of things, but more toward describing common definitions for broad classes of things at the application level, like switches and on-off controls. So thing description basically describes instances of things using the same descriptive ontology of actions, properties, and events. And it then has these protocol bindings. It has a specific enum. It has a form that points to a network address where you can go do this. And basically, we're using the default operations here, but with the form, you could tell it to use put instead of post or patch. You could do a lot of different things with the form. So basically, the thing description it adds the bound protocols and bound representations. Now, what we wanted to, I guess I should stop there and sort of see if there are any questions or comments before we get on to the real topic, which is templates. Okay. Going to work from the GitHub issue. Sebastian asked me to just work from this. I think there's been some introduction of thing description templates, and then those folks in the WAT working group, please help me out here. But basically, a thing so thing descriptions themselves have a lot of requirements and constraints, and they have they're required to be complete. And what we realize is that we very often have a lot of reasons to make instances of thing description like entities that aren't complete thing descriptions. They probably one of the use cases is to have a thing description template that is a thing description but doesn't have the web address. It might have a partial protocol binding. It might have the data schemas, but it might not have the forms, or it might have the data schemas and the forms, but not the href part. And the idea is that you can build these templates as building blocks for thing descriptions, essentially, and really a number of different ways that you might use them in the workflow. But this is really what we're working on, is trying to figure out what these look like. And so we thought, well, what would first thing description templates and one data model SDF definitions have some common attributes, but some differences as well. So, the one thing I say about one data model definitions is that they provide stable URIs for all of the things that are defined. So they're basically a vocabulary reference, if you will, and somewhat an ontology reference. They have simple relations, like things have objects and objects have events, actions, and properties, and more like has a relation, where thing descriptions are more like directly describes the affordances and has a little more semantics through RDF. But essentially, the classes still line up actions, events, properties. So these are what we started off with in looking at as one of the working threads or work streams in these designing templates, was looking at how one DM SDF instances, if you will, and thing description template instances might work together, or can we use thing description templates to create definitions the way we do with one data model, or do we use them in some other way? So what are the use cases and how do they map and overlap? So here's what we sort of looked at is how would we use these, and I think this is a very similar kind of description. So we basically thought, well, yeah, this is really the same idea that I just showed. So this is not an instrumented TD though, this is basically to say, well, what could we do if we translated the one data model to a thing description template? So we basically say their actions, on and off actions, their state. And this is essentially an enum definition here. It's an interesting way of defining an enum in JSON schema, but it essentially produces the same constraint that saying enum on off does. But this was sort of automatically translated through an algorithm. So instead of just translating it directly as an enum, it went into, and let me just show you the source file again. It went into this enum definition and actually pulled out the constraints as they're expressed here. And so you see, rather than just have it defined as enum on-off constraint like that, the translation that Sebastian produced unwrapped or mapped it one-to-one, if you will, from the source definition. But other than that, it's the same as saying enum. So basically, this is a translation of the definition as opposed to an annotation of a TD with the terms in one data model.
Michael, can you take questions now?
Yes.
Michael?
Hi, Michael Costa, Michael Agali. Just a very simple question. So here we define a mapping, but does anybody know that the string constant on actually has the semantics of switching something on? Is that part of SDF, or how is this information conveyed?
Well, that's an interesting question. When you say how does it actually convey the semantics of that, what would there are basically a lot of layers to that, right? So the SDF definition. So currently SDF is in development. So this construct you see, SDF enum, is not officially part of the language. It's one of the extension points that we're working on in order to allow SDF to do what you just asked about, and that is to, rather than just saying here's an enum that's on off, in other words, enum on off like this. And this is really how we could say this in SDF as well today without the SDF enum. But SDF enum is meant to provide a URI reference for each term in the enum, for each choice the enum offers, and then allow it to have its own set of descriptors and constraints. So currently, what we've done in this example is only provided a default. Well, this should actually probably say default and not constant, because you should be able to override it. But you might want to do it the other way also and fix it. But currently, for semantic depth, we're only really providing a human readable description that says the on state and the off state. Now you could expand that and have more human readable description. But when you start getting into machine readable descriptions of there are a lot of different ways you could go. And one of the ways that we're looking at is, well, how could we add a state machine language to describe on and off as two different states? That would get a little closer to talking about what's supposed to happen, but it still doesn't really say what on and off mean. In fact, that may even acquire special meaning according to the device that the on-off switch. On-off switch here, the definition is meant to be reusable across a wide range of devices. So exactly what is meant by on and off state is probably different for each device. So I guess that's a long answer, but I think it's a really interesting topic, and I'd like to hear your thoughts on what would be relevant for you in, say, a digital twin environment for a description of how could we extend this model to help semantically make digital twin models easier to build, right? I think that would be one good question.
We have one more Michael who wants to weigh in. Michael McCool.
Yeah, so I think at some point the semantics is the link or the URL that points to a particular definition in SDF. And it's kind of the human's understanding of what that definition means.
So we all looked at those and we all made an agreement about what it means. Yeah, that's
So it's a consensus. Yeah. And so That said, we still need to have precise definitions of what each of these states means in a human readable format. So for example, does on mean the switch is closed or open or whatever, right?
Well, again, for a device, like for an electrical switch, like a knife switch, on does mean that the switch is closed.
Yeah, but you can have negative logic too. So I guess the point is that
You could even have other devices where on might be that some mode is enabled.
Right. So I think it's an example, and I think we need to have precise definitions. But I think at the end of the day, the link, a persistent link to a given definition is in fact the semantics. Once we all have a consensual agreement on what that label means, and then we use @type to refer to it.
The point that the example that Michael is showing is illustrating, if we omit the description and if we give this to somebody who does not speak English, it does not have any meaning. It has a constant, it has two strings, which consist of 2 or 3 characters, but it does not convey any kind of behavior in terms of turning something on or off, or yeah.
Right. Well, I think what it boils down to is what is the grounding? What is the final definition that everything is built upon? I think in this case is in fact the English description.
So right. I have some examples that I'm not showing here because they're more verbose, but they point to Wikipedia definitions and things, for example. Why not, right? And then you can go say, oh, on and off. Well, those, you can look them up on Wikipedia, and you can. The other thing that we do, just briefly, with SmartThings, we don't really need machine readable semantics, but we need human readable semantics across the globe. So we need good systems for internationalization. And a system like this of enums allows you to put in labels that can be internationalized through some standard directory systems, for example. And that tends to work out pretty good for that case. And then maybe there are some machine readable directories that could be useful from IEEE 61499 or systems like that also, right?
So I think we're falling back a little bit behind what we already had established, which is that we do need those vocabularies. So on and off may be trivial for you, but if you are talking about cheese firmness, which is our standard example for that, the various grades of cheese firmness are not going to familiar to a lot of people. So you want to be able to have a source for the definitions of cheese firmness, and the same thing is true for on and off and all the other things as well. So we need those semantic references at some point. The language doesn't currently provide that, so SDF 1.0 doesn't even have the SDF enum in it that Michael used here. So that's kind of the next step. So we have 2 people in the list, Kaz and Michael McCool. So Kaz, do you want to talk next?
So yeah, this thank you very much first, Michael Costa. So this SDF approach is very interesting. On the other hand, I was wondering whether it would be really appropriate and nice or easier to use this JSON-based format to handle state transition in general. So for example, W3 actually has a standard for state transition control itself, and 10 years ago, and also there was a payload data model named Emma as well. So this kind of combination might be easier to handle the combination of step transition itself and the data model itself. So that's why I personally think it might be easier to handle the whole mechanism if we combine sync decision kind of data model and genuine state transition mechanism. It's, separately.
Cool.
Yeah, and actually, I have kind of a meta question. So putting aside the issue of how do we define semantics formally, which is a very, very deep hole, I'd like to talk about just the process for how we kind of make progress here. So we have the what thing description that supports descriptions of device instances. We have SDF, which supports high-level descriptions of semantics of devices. So what is our path forward for a formal relationship? I think we have several different ways in which they can be used together. I think we have a bunch of examples. I think maybe we need to talk about if we were going to formally cite SDF inside, say, the new TD spec, what role would we put it into, and what would we recommend people to do? And also, aside of this, is also certain features in SDF that don't have a corresponding aspect in TDs, like, for example, SDF objects, that we probably need to figure out how to do the mapping of. So can we address the process issue? How do we make progress here?
Okay, so let's get back to the GitHub issue, because we've got a few, we sort of move in that direction, right? So that's what we've done. Let's see, there's some ideas of using links to link to concepts, and how do we actually do that? I think there was some discussion. Maybe not. Okay, sorry, it's not here after all. So I had a slide. There's some discussion about workflow and how this is actually, in the workflow, and clearly it makes sense to use these definitions as annotation in a TD, and we should probably just bring that into the Plugfest, because I pointed to these in the playground. They exist. Anyone can use them. They're relatively stable. So if we want to use these definitions in Plugfest from motion sensor definitions or whatever, I think we could do that. We could do that tomorrow, right? Exactly. I mean, literally tomorrow, because they're all there and they're all defined. And there's plenty there. There's like, I don't know, looks like a couple hundred of them. I think the bigger question is around the new spec and templates, and how we construct templates, and what the relationship of SDF to templates are. Now, SDF has basically attracted the device specifiers and makers for the most part, and also a lot of folks who want to just engage developer tools to write down their definitions in JSON. And so what we've done is provided a real simple, just to give you an idea of where we think SDF is going in DM. There's this organization SunSpec that makes solar energy, residential solar energy models that are used in controllers and in energy accounting and things like that. That not exactly like what's in Zigbee Energy, but it's kind of similar to that. Also, just Zigbee Energy, the folks that work in Zigbee Energy are really interested in having these bigger, broader models to work with, and not just be constrained with the device models that are literally for constrained devices. So there are going to be a lot of things that are semantically defined, but there's no real obvious way to use them. There's no protocol binding, so SunSpec will have their sort of way of using whatever they have, RMI system they're using or whatever. Google Weave will have to convert them to protobuf files to use them in Weave, things like that, right? So basically there's some conversion. I think what we could do is make thing description really easy to use. And I think the question is how these templates work. And the main question we're revolving around right now, I think, is whether we translate, and I think this is true of IoT schema as well, the same question, whether we take these 1DM definitions in JSON and translate them to thing description templates and provide anchor URIs in the thing description namespace, or we make templates that still link back to the 1DM models. And that's, I think there are some advantages and disadvantages of doing both. What's possible, though, I think is, and I think the easiest way to reuse them, so we have to think about what happens when a 1DM model changes. we're going to rely on those as source data, we probably don't want to just copy them forward. We probably want to link to them so that we can easily expand the definitions. So what I expect, or what I would propose we look at, is when we create a theme description template, point to the one DM space that you're representing, if you know, as if you really want to reuse the one DM definition, and then add the semantics in the TD template that are needed to get it closer to. So that by that I mean add the payload definition if you want additional constraints. Select which definitions are actually present in the instance. So if I'm making a TD template, I could see this being useful as a device manufacturer. If I wanted to organize my device builders, I would use TD templates that are anchored in one DM concepts so that they're interoperable with other devices. But those TD templates then would have my protocol binding. So they would have the profile. If I was going to use the Watt profile, those TD templates would be Watt profile. So
I guess
right,
to summarize,
one way is right to have a bunch of different templates that are tailored to different implementations of the different basic models, basically.
So I guess one thing we should do then is when we define TD templates, do it with an eye towards interoperability with one data model. And so, for example, if we have a modularity construct in TD templates, we should figure out how that maps onto objects in
yeah. So the current discussion is that you can make a TD template for an object, and then you can figure out how to combine those templates in your device design according to your own way of making your device TDs. But that's still, maybe there should be a web profile standard way of Watt profile standard way of doing that.
Right. So I think there's a set of activities around specification alignment. I think there's another set of activities around examples and best practices and kind of more informative things, which could go in an appendix in the spec. I think there's a third class of activities, which is tooling, right? Which is if there's an automatic way to do things, people are more likely to use it. So is there a way we can automatically generate TD templates that map to SDF files or whatever? And if that can be run kind of as a CI activity so that there's always an up-to-date set of templates available for every current SDF definition, that would be kind of very cool.
Well, this might inform some of the questions about what level templates operate at, and I think the answer is all of them in a way, because I could see there being a base TD template that has no more information than an SDF file, maybe even less, but typically no more. In other words, it doesn't add any constraints. It just translates it to TD, and gives it a context and brings it into the linked data world. Then, on that, I could say, well, now I have a way of building it for CoAP, right? A way of building it for HTML or MQTT or Smart Things or whatever. And I could see that as being a really useful, and then that could be driven through CI. And this is really what I was encouraging us to do in the template design, whatever, the template design work, is to think about the workflows and think about where people are going to need to use templates and what, sort of like I can really think of the main use case being, I want templates to be building blocks so I can easily create whole TDs and manage the modularity of products and services. But there could be other use cases. But I think that's the one that I'm proposing to start with.
So Michael Lagerly?
Yeah.
So maybe just a very high level and generic question. I understand there is a set of defined building blocks in a way in terms of SDF in these examples. And I think I understand I can compose them and build some kind of aggregates of these objects. If I just look into the capabilities of a TD and into the expressiveness of SDF, can I express things with SDF that I cannot express in a TD, or vice versa? Can I express things in a TD that I cannot express in SDF, or is there a one-to-one mapping possible?
And what I think what you just said is really key. You can express things in SDF that we have not provided in TD, such as like the full set of constraints. But there aren't that many, because SDF is meant to be just a defining of the basic classes for things. But there are some things we have in SDF that aren't in TD that have to do with what we call qualities. And there are some, mainly in SDF, there are compositional things and modularity features that aren't in TD, as McCool was getting at earlier. There's this layering of SDF object and SDF thing where you can define even reusable things as components for more complex things. And that doesn't exist in TD. So that's actually, but TD only describes instances, so maybe that's you know, as we said, well, that's kind of up to how you build instances. We don't have a standard way to do that. It's a punt, because really when you try to do it, there are some issues, and you would like to have the modular semantics as well. You'd like to know that your light bulb has on-off color control and dimming and energy measurement. You'd especially like to know that it has energy measurement, so you can put it into the things that you can measure energy on, for example.
But I think it's worth mentioning that there are a lot of things that you can do in TD that are not in SDF. So for instance,
that's where I was going to go next. Thank you. Go ahead.
We don't have protocol bindings and so on. So one of the points about the SDF effort is to make it really easy to map the existing data models into SDF, and preferably back. And so the focus really has been on model interoperability. And that's a very different focus from the one that TD had. And I think that's why the results look so different. But of course, the next step is to make sure that we have model interoperability at that level as well. So right now,
when
TD
you
is about
say,
network interoperability.
sorry, just a question on that one. Carsten, when you say existing data models, you refer to OCF models or to something else in addition? Or something completely different?
Zigbee, Bluetooth, whatever you have out there.
Mm-hmm. Thank you.
Each of these organizations has 100 or a couple hundred data models already. And what we are trying to do is find a way to translate all these data models into a common language and back. And that, of course, creates the need for some compromises on expressibility. So we are not in the business of extending SDF a lot just because there's that one model over there we cannot map. We are currently more in the process of making sure we can access all those ecosystems first.
Mm-hmm. Okay, that makes it clear. Thank you.
And, you know, we have even got to the point of some of those ecosystem folks looking at SDF and looking what other folks have contributed and kind of thinking about extending their ecosystem. So that might be the pace at which SDF common evolves, even though we have extension points that we can use to get out ahead of things a little bit too. I think we covered most of the things with templates, like where we are, and you know, we have an example of what a template looks like that corresponds to an SDF definition, and we have some kind of framing for the discussion going forward. So I don't have any more points to make. If there are any more questions or discussion,
at the end of our slot. So we're exactly at the time when the slot was supposed to end. So I think one question was what is the way forward, and I think there is going to be a lot of discussion of this in the next few wishy calls. So that's maybe the best place for people who are really interested in making these various approaches work together can go to. And so right now we have SDF 1.0, which was published on last Friday. And the next step, of course, will be to do an SDF 1.1 and not drop in the kitchen sink, but really put in those features we need to widen the scope do even more things, Bluetooth, Zigbee, and so on. And I'm sure we will discuss these things in the Wishy calls over time.
And we can start working with this in the Watt Plug Fest immediately.
Yes.
We also have a semantic proxy project that we're going to be working in the Watt Plug Fest that I need to document and enter. So yeah, stay tuned.
Okay, let's follow up in the Watt Plug Fest. And Michael, you will be at that, the Watt Plug Fest?
Well, as much as I can do with this semantic proxy that we're working on.
So let's follow up there then for next, and then in the next Wishy call on the 30th.
Yeah, the semantic proxy uses node Watt, and it actually uses whatever Ege is calling his thing. I forget. Anyway, it's virtual thing. Yeah, it uses virtual thing.
And Michael, a question about the Plugfest. Are also non-Web of Things members, are they able to join one way or the other, the Web of Things Plugfest?
Yes. And I mean, technically we could invite you, but if you're interested in joining the Watt Plug Fest, give me a ring and I will forward you the WebEx so you can come in. I would say it's an open invitation to people who are interested in working on IoT stuff. The WebEx is not public just because we avoid spammers. So just email me and I can email you the WebEx.
So Kaz is asking whether we are talking about the Plugfest next week, and the answer, I think, is yes.
Yes, and there's also the same wiki page as used for the workshop originally is also used for the Plugfest, so you can link back to that from the agenda page if you wish. Minutes.
Great. So I think it's good that we have generated this visibility, this mutual visibility here, and we need to pick up these communication channels to make sure what we are doing is eventually converging. So this is just one step, and we will need a few more steps to get there. The last item on the agenda is hypermedia controls in thing descriptions. And Ege Kauken has pointers to two W3C Watt proposals on doing that. So Ege, do you want to go ahead and talk about those? Can you share your screen?
Sure. Do you hear me?
Yes.
Okay. So do you see my screen with the GitHub?
It's pretty small. So if you maybe can press a few times.
That is difficult, but I can do maybe this. Did it change anything? Okay. Yes. So hello everyone. I wanted to introduce the hypermedia proposals that we have in the thing description repository. These proposals are in this proposals folder, and there are two of them. So hypermedia control and hypermedia control 2. So the first one is proposed by Victor Sharpenay, and the second one is proposed by me. Since the second one is based on the use case of the first one, I will start with the first one. I will also just quickly check if Victor is here. Yes, he is here. Okay. Yes, so I'll start with the first one. Okay, Victor is, yeah, okay. Yeah, so since we have time, I will start with explaining the whole idea. And basically, until now, in thing descriptions, we had actions that were so we are focusing mostly on actions, but maybe it could be applied to other interaction affordances. But basically, until now, in thing descriptions, we had actions that would be started by the client or the consumer, and but we would not do anything more on the actions. So basically, they would be started. Maybe the response would return something, maybe nothing. So in case we are fading a light, it would fade, and we wouldn't be able to know anything more about the ongoing operation. And since there's already some sort of existing implementations regarding hypermedia, we such as the Mozilla implementation and the Oracle device cloud, we want to be able to describe the hypermedia use cases in thing descriptions. So the first one, so the example that the both proposals use is a light that fades to a certain value or for a certain amount of time when the client invokes it. So we can assume that this takes like a long time, let's say more than a couple seconds. Yeah, so we say that you can post to this fade URI, which will start the action, as you can see below, and then we can do a GET request to sort of query and like know the status of the action, and the thing responds to us, and then we can change the action while it's still ongoing or while it's pending to another value, so that in case we want to do fade for 2 seconds, we can now fade for 5 seconds, or we can actually stop the action, ongoing action. So it's important to note that there is the /1 at the end of the URI, which is reflected at this ID field at the end of the URIs. So this 1 is generated by the thing. Exactly. So as it is stated, the first request is very much possible in the current standard, but the subsequent requests on the created resource are not easily describable. Yeah. So in the usual case, we would have something a thing description like this. So we have an action that fades, that takes an amber duration in milliseconds, and this is understandable completely by with the current thing, with the current consumer of this thing. Okay. Exactly. So as we know, hypermedia in general means that we can expect that the thing indicates to the consumer what can it do later on with the created resources. So in this case, is that if the thing answers with 201, fade 1, we can do some further operations on this fade 1. And in our case, the further operations that we can do is such as get, put, and delete, and what they would actually do to the action. So what it means is like what these methods, which are protocol specific, would imply, so that it would update, cancel, for example, the action. Exactly. So quite simply, the idea is to learn about so once the post operation is done, to learn about the upcoming or the subsequent operations. So the argument that also differs the two proposals is that here we want to not explain, in this case, all the possible interactions in a certain sequence or not in the thing description, since it will so overload the TD. And the more concrete difference is that this proposal allows for piecewise consumption of TDs, or where we can have TDs that change over time based on the
state of the thing.
Exactly.
I see there is a question already.
Yes. Michael?
Oh, just some comments. So there's straight two issues that use cases. So one is, do I have all the information up front as a developer to understand the API completely for a thing? So that's one issue. How do I get a complete description of all possible interactions that my code might have to deal with? The other is, are TDs static or dynamic? I just want to point out the dynamic TDs have all kinds of complications with registering directories, signing, identifiers, etc.
So in this concrete proposal, it's dynamic TDs.
Right. I'm just saying there's going to be complications and trade-offs.
Yes.
Versus when we have dynamic and incremental versus static and complete.
Yes, I will come to the differences between the two proposals. There's also a nice comment from Daniel that highlights some of the differences we have. Okay.
If I can continue if you want.
Sure.
About this proposal. So far there was activity in my office. Sorry for that. I couldn't really talk. So the essential idea of the proposal is to reuse the hypermedia vocabulary that is defined as a module of the thing description model. So for every new affordance the thing provides, there would be a new form somewhere in the thing description. And we wouldn't need to add much to the thing description model to allow for this. We would only need to create new operation types. Currently, there is no operation type for the cancellation of an action or the update of an action. And these operation types would be needed.
Should I scroll down, by the way? You can tell me, or do you want to share your screen?
It's fine. I was more or less done. This was the general idea, and then there were different possibilities as to how to expose these new forms. Right, and you can go on with your proposal more specifically.
Okay. Yes. So as Victor mentioned, these forms can be appended to the forms array of the thing once this resource is created. So the consumer could reconsume the thing. So like this, basically. So if we get a thing description, we do a post request, and then once we know that it results in creation of a resource, we get the thing description back and then learn what is possible. Yeah. So this part is an extension from my point of view, regarding different versions of the thing description as well. So I go on to this new operation types that Victor mentioned. So the proposal includes read action, update action, and cancel action that are then mapped to the get, put, post in the case of HTTP, where they appear in these newly created forms. And additionally, in the current case, the invoke action operation has the input and output fields that corresponds to its payload. And here we can also have such terms in the action level that correspond to the payload of the update or cancellation. So here, like usual, the input is what we use to invoke the action, and here you can see the update, which also takes a number. And then these are then mapped to the forms here, where you also see the new operation types. And this TD is also what is created once the FADE1 resource is created. Yes. Yes, so this is mostly it. It's also important to note that the output isn't the data, that sort of payload of the response of the initial post request, but it is the representation of the action, so the result of the read action. Yes, so there is some more material in this regarding event and some other aspects, but I think we can skip them for today. Or yeah, so if this is, if you think that's all about this proposal, I'll go to the next one, Victor.
Yes, sure, go on.
Okay. Okay, so this is the second proposal. Very similarly, we have the new operation types, we have the new fields. I just called it query action instead of read action in this way. And what is different is that for each of these terms that are on the action level, so not the operation types, they also have input and output fields. And this is again like the previous case. This is the fade operation, and again a simple thing description that is the respecting the current standard. Exactly. So the hypermedia use case is similarly, it's exactly the same as what Victor has proposed. It's just that I also thought of having static IDs. So in case we cannot do pending actions, we can just reject an action if we cannot start it at the moment. So we wouldn't maybe need dynamic IDs. So here is then the possible request that could be made. So it's just without the responses, because I think that is what gets it complicated. Exactly. So as Victor said, we cannot know what to do with how to do the subsequent operations. So the get, put, and delete. However, basically in this case, we have all the operations and the forms that are statically put into the thing description. And as you can see, we can have a variable ID or sorry, dynamic href, or it could be static. Yes, so basically with this, like the case of Victor, we solve how to do the subsequent operations. But of course, the consumer has to know that invoke action should be what is done the first. So in contrast to Victor's proposal, in the Victor's case, only invoke action can be done in the beginning. Then it's very clear what the thing should do first. Whereas in this case, the thing has to know that invoke action has to be the first thing that needs to be done with the thing. That these are indeed subsequent operations, the other three. Yes, so in this case, the ID is not clear how to get the ID. We can ignore it if the ID is always static. Also, at the same time, it is not clear how the request payload or the response payload for different operations should be. And the takeaway from this is to is that in case the href of different forms are dynamic, we need a way to describe how this is retrieved, and we will need to be able to better express the different request and response payloads of an action. So I start with the second one and then go to the first one. But very simply, here I add these three different terms. So query, action, so query, update, and cancel on the action level that all have input and output fields. So if we think of a sort of a tree, we'd always, let's say, have the title, and then in the actions for the fade, we have the usual input and output, but then we can have these other fields which all have, again, input and output. So these are on the same level as so they're on the action level. And so similar to the invoke action, so if the cancel member isn't present, that means that the cancel action doesn't expect a payload or similarly. So if one is not present, it just means that there is no payload associated. Thus, in this case, the payload would look like the following. Sorry, the TD would look like the following, where we have the query, which gives a payload at the response. That includes the brightness value, the current brightness, and then it can also tell the status of the action. And then we can have, like, as usual, the update and so on. And this hasn't changed from the previous one. So these have either dynamic IDs or static ones. So we will go into this now. Oh, wait, there are actually 3 questions. Maybe I let's take the questions first. Or should I finish?
Well, I think my question is related to what you're talking about. Now you're talking about the first proposal or the second one? This is the second one.
Second, yeah.
Yeah, so I just wanted to address the issue of URI templates. So one of the things you've done here is you've put in the different options down under forms under action. And if you can just scroll up on this example, please.
So you mean the payloads?
Yeah, so these all share, the same thing on action. So to me, the logical thing to do would be to have for each different thing I can do with an action, create, cancel, request status, etc. I should have input and output data schemas for those interactions.
Yes.
And it seems to be the logical thing to do is to be able to define, if I use the same name for an element of a data schema, then it actually corresponds to the same entity. So for example, if I create an action and I get back a result that I label as an ID, then I later on have a URI template where I define an ID to be used in that URI template, I think we could simply say those are the same thing, so that the system understands that that data is to be carried forward from the response back into the other interaction. However, I think the structure here isn't quite right because we have, a data schema and then we have a bunch of forms, and we actually need data schemas per transaction, I think, because it can be different. I don't think that's quite captured by the structure.
Sorry, I didn't understand data schema per transaction.
You have these forms, right? And these different, cancel or whatever. But in fact, the payloads can be different for those different interactions, right?
Exactly. So, for example, the query action operation has this as the.
Okay, so you actually identify the data schema support. Okay, so I think we simply add the rule here that if a given name for a data schema element is reused, that they are be interpreted as being the same thing. That allows us to have a rule that's to carry data, from a response back to a further interaction.
Ah, I see.
So if I say ID, for example, in the URI template later on, and I have ID as a response from my post, I should be able
I will come to this actually. Yeah, this is a specific case. I will come to this point.
Okay, great.
We have about 4 minutes left, 2 people in the queue.
Okay, maybe then I finish this such that then maybe we have all the questions ready. Sorry, so Zoltan and Victor, I'll just finish this quickly. Okay, then so about the dynamic hrefs, by the way, so as Klaus had pointed out on Friday, we could have the entire href as a variable. So it could be that there's only the ID in the href. Okay, then for the case of HTTP, so how can we construct the dynamic hrefs? So as the HTTP standard and like Mozilla Web Network tells, is that in the status code of 201, so in the response that has 201 in the status code, it can actually be that this location is supplied in the header of the response, or it could be in the body of the response. So in case it is in the header, then we would have to have a form like this, where we say that the headers are like this, where the location, so it's always called location by the standard. And then this ID should be then remapped back to the forms that we had shown before. And the consumer should understand that this is the headers of the response and not the request that it has to supply, for example. But location is, I think, always in the response. And then if it is in the body of the response, then we would have to have a TD where we have the inputs again, but then the response of this first post operation has an, let's say, a key called href, and then this is linked back to ID. I am not super satisfied with this way, but I am open for proposals on how this could be done. Yes, and then basically the rest is as before. Yes. Yeah, so I have some observation regarding scripting API, but I think we can skip it for now. And I also have an example, but I think we have not enough time for all this. So let's get the questions. So the next one was Zoltan.
Yeah, I wanted to ask that. So it looks like you have 3 standard actions associated to an action. And in some cases, I would prefer to configure some events for the updates and an action for the canceling, which leads to the question that if it would return something like a thing, it would be easier to model with properties, actions, and events what is possible to do on that interaction. So I understand we don't want to use things for abstract things, but we could call it something, and then it would be valid in the context of that interaction. So has that been explored?
So like a separate property interaction affordance under properties that is like, let's say, can be observed so that you get like the updates back for the event.
Yeah, depending on the use case, an event would be more efficient probably than calling an action repeatedly over the network.
I think that would be also like, this is something I didn't consider. Maybe we can also be able to describe this in some way. I just also don't know if this is an existing approach like in the hypermedia circles. But I didn't think of it yet. That's a good point.
Victor?
A question about the very last thing you said about the ID in curly brackets. Where do you...
This one?
Yes, here. That requires to have a URI variables field as well, right? And I mean, in the thing description there, you should define what this URI variable refers to.
This is a good point. However, I think the URI variables are more the URI, like not for URI templating, but it's actually the data you send in the URI with the after the resource with the question mark, like the query parameters, so to say. Or can this be also used for this? I don't know.
Here, the ID may not be a URI.
Exactly. Yeah, that's why.
It can be the input of some further action to invoke. So
you mean like the question mark Q equals like ID equals something after the href?
yes. In any case, you have to say that this ID is a control. It's part of a form to perform more actions.
Yes. So this has to be somehow linked back, and this is the part that I'm not super satisfied with, like linking this information that comes in the href of the payload to a form.
Okay. And by the way, there was the proposal to use OpenAPI, because what you're suggesting is really rewriting of OpenAPI. But OpenAPI doesn't solve this problem either. So this is a really open question for hypermedia controls in general.
Okay, I think that's an interesting discussion, because we're running into the problem that even the established mechanisms like OpenAPI cannot really do what we are trying to do. So we have to do some new design work. And I'd love to propose how to do this in SDF. It's rather obvious, but we don't have time today. So let's continue this discussion in the next Wishy call.
Another way to discuss this is there's an API specification conference coming up, which will actually involve OpenAPI as well as others. And we're contemplating doing a submission into that. This might be a really interesting topic to bring up in that community. And I think it'd be interesting also if the Wishy people also participated. So I didn't bring it up earlier, but I think it'd be interesting to look at this conference as a venue for discussion with a wider group.
Who is we?
The Web of Things, we've been discussing this in the main call, whether to participate in the API specification conference. We have an issue discussing that right now. And actually I noticed Ege posted abstract. I do think this topic of how to handle hypermedia controls is a very interesting one and is likely to be a subject of conversation at that conference, even if we don't bring it up.
I have pasted the link of this issue.
Yeah, great.
Okay, so thank you for contributing to this slot. Ari, do you want to do a quick wrap up?
Well, yeah, it's going to be a very quick one, given we're 4 minutes overtime, but thank you everyone for very good discussions, and clearly there's much more interesting work for all of us to be doing together. So as Carsten pointed out already, I think we can use the upcoming Wishy calls to take more focused step on the specific items that we have discovered today, and we certainly need to keep on going on this ongoing work on aligning thing description templates and thing description and 1DM SDF. But I think the next Wishy call is going to be a good venue for all of those. So looking forward to see as many of you as possible on June 30th Wishy call. It's going to be most likely on a later time than usual. So also people from US should be able to join it. But apologies for everyone in Asia for that particular instance.
And I'll capture the URL
all I had in mind.
Our wiki page as well.
Perfect, thanks. Carsten, anything you want to say to wrap up?
Yeah, I just wanted to point to the link with the agenda to the next Wishy call. We will certainly have some form of thing-to-thing research group meeting again in the second half of July, but we are still trying to find out the details for that. So for now, thank you all for joining, and hopefully see you in that research group meeting. Thank you. Bye-bye.
Bye-bye.
Thanks, everyone. Bye.
Thank you.